Hey guys, and welcome back to the Foundations of Algebra course. In our last lesson, we finally got to see the essence of algebra. And in today's lesson, we'll push on and study the individual operations. So let's get right to it. We understand that algebra is the study of the operations on the real numbers. And in terms of operations, we know that there are only two, addition and multiplication. Today's lesson will focus on addition. The good news is that we already know everything we need to know about addition to make the jump to algebra. It's going to be the same. That's the beauty of how we handled this. So just as a reminder, the main principle of addition states the only things you can never add are the same things. And when you add the same things, you get the same things back. If you can keep that in mind, you will be all set. Okay, let's put it to work. As a quick warm-up, let's just sort of stretch out a little bit mentally and ask ourselves, can you add dogs and dogs? Well, those are the same things, right? So yes, you can add dogs and dogs. How about cats and cats? Yes, they're the same things, all right? And dogs and cats? No. Good. Don't let the head nod fool you. Dogs and cats are not the same thing, so we can't add them. Let me clarify what I mean by that. So for example, if you had 3 dogs plus 2 dogs, well, we just said dogs and dogs, they're the same thing, so you can add them. And when you add dogs and dogs, you get dogs, okay? The most important part of today's lesson is this emphasis on the things, okay? Dogs and dogs, yes, you can add them, that's 1. And 2, when you add dogs and dogs, you get dogs. How many? Well, that's the easy part for us at this point. We got 3 of them, we add 2 more of them, we get 5 of them. That's it, okay? In contrast, if you had 3 dogs plus 2 cats, you can't add them. Okay? You absolutely can't add them. And what I mean by that is that you just get 3 dogs plus 2 cats. That you can't combine them. So we just say, no, can't add them. All right? Let's put this to work. All right. We're being asked to add if possible. And if not, we'll just write NP for not possible. All right? Check this one out. 3x squared y plus 11x squared y. So the first order of business is to look at the things. Can we add x squared y's to x squared y's? Shout it out. Good. Yes, they are the same things. So we can add them. And the second part of the main principle, when you add x squared y's to x squared y's, you get x squared y's. How many? Well, you just go off to the side. I mean, we got this. This is just like the dogs and dogs. 3 plus 11, well, that's just 14. All right, boom, throw the 14 in there, game over. It's all about the things. Got it? All right, how about this? 1/3 x to the 4th plus 1/2 x to the 4th. So again, main principle, can we add x to the 4ths to x to the 4ths? Yes, they're the same things. And part 2, when you add x to the 4ths to x to the 4ths, you better get x to the 4ths. Okay? When you add the same things, you get those same things back. All right, how many? All right, well, again, just go off to the side and let's add them up. Let's see, we got 1/3 of them, and then we got another half. So 1/3 plus 1/2. All right, well, we need to get a CD. They got to be the same thing. Let's use sixths. So I'll multiply by 1. This is 2/6 plus 3/6. Okay, I know you guys got this. Take your time when you're working on these, but you got this. So 2/6 plus 3/6 is 5/6. All right, boom, there it is. Throw it in, and we got it. All right, next one. How about x to the 4th, 3x to the 4th plus 5x to the 7th. So x to the 4th and x to the 7th, yell it out. Yes or no? Can we add them? Ooh, okay, I heard a mix of yeses and nos. The people that were saying yes, I think I understand why you might be saying or thinking yes, because it's totally reasonable. Probably because both of the things have x's in them. You know, there's x to the 4th and x to the 7th. But the whole thing has to be exactly the same. And x to the fourth is the whole thing in the first term, and x to the seventh in the second. So they got to be exactly the same. So in this case, we cannot add x to the fourths and x to the sevenths. They're different. So for our answer, we'll just write NP, not possible. Cool? Keep your eye on those things. That's the most important part of this today. All right, here's another one. Negative 16 square root of AB plus 12 square root of AB. Well, again, same question. Can we add square root of ABs to square root of ABs? You betcha. They're the same. And when you add square root of ABs to square root of ABs, you get square root of ABs. When you add the same things, you get the same thing. Now to figure out how many, just come off to the side. Negative 16 plus 12. That's what we got to figure out, right? You can do it with N's and P's. You can do it in your head. However you do it, we get negative 4. Throw it in place. Game over. We got this. Excellent job. All right. How about 5x to the fourth y squared plus x to the fourth y squared? This time, x to the fourth y squared is the thing. Can we add x to the fourth y squares to x to the fourth y squareds? Yes, they're the same. And when we do, we get x to the fourth y squareds. How many? All right, in the first term, so we're going to come up to the side. We got 5 of them plus, this is interesting. Notice it doesn't even look like there's a number there. Well, there is a number there, but mathematicians, you know, we all are notoriously lazy, right? We don't want to write anything we don't have to. So if you don't see a number in that spot in front of those things, we call it a coefficient. If you don't see a number there, there's a 1. Okay, so there's really an unwritten 1. I'll write it there for right now, just so we have that in our notes. So 5 of them plus 1 more of them. There we go. We got 6 of them. Nothing to it. Throw it in place, and you're done. Looking okay? Here, use it. How about x to the third plus x to the third? Can we add x to the thirds to x to the thirds? Of course. Yep. Yes, they're the same things, and we know we're going to get x to the thirds back. Don't be tempted to write something crazy like, I don't know, x to the 6 or something weird. When you add the same things, you get the same things back. X to the thirds and x to the thirds give you x to the thirds. All right, well, now we know how many we have in each one. After our last slide, we know that we have 1 plus 1 more of them, so we're getting 2 of them. We got this. Algebra's not too bad, is it? Awesome. 2x cubed. Very nice. All right, let's throw all this together. Here's how this will often come at us in our work. So they ask us to simplify completely by adding wherever possible. So we're going to simplify this expression. Notice we got all these different terms lying around. And maybe we can put some of them together through addition. So let's take a look. So how about we start with the first term right here. I'm going to underline it here. We have negative 2x to the fifth. So x to the fifths. Do you see any more x to the fifths? Good. Yes, in the third term right here. Excellent. So I'm gonna record this right over here. Negative 2x to the fifth plus 6x to the fifth. All right. Well, obviously they're the same. That's why we wrote them together. They're the same things. So when you add x to the fifth to x to the fifth, you get more x to the fifths. How many? Negative 2 plus 6 of them. Negative 2 plus 6. Is that something you can do in your head at this point? If not, you can write it down off to the side. But I'm going to do the N's and P's in my brain. It looks like I got 4 positives left after they annihilate each other. 4x to the fifth. Good. All right. How about this one? We've got y to the fifths. Are there any other y to the fifths? Nah, don't see it. All right, so he's just going to be by himself. It's too bad. But okay, let's move on. 8xy is our next term right here. So the things are xy's. Any other xy's? Nah. All right, we got another lonely guy. Lonely term there, 8xy. And last but not least, how about x to the 8th plus x to the 8th? Can we add them? Yeah, this looks a lot like our last one, doesn't it? X to the 8th plus x to the 8th. Good. we're going to get x to the 8ths back, right? When we add the same things, we get the same things. And now we know that we got one of them plus one more of them for a total of 2. Look at that. I'm going to just bubble this in. This is kind of like our side work, okay? So our answer here is going to be 4x to the 5th plus 3y to the 5th. I'm just going right down our list of bubbled information here. 8 plus 8xy plus 2x to the 8th. And that's all there is to it. It's pretty amazing stuff, isn't it? I love how our knowledge of addition from before is really paying off here. All you have to do is keep your eyes on those things, and you got this. All right, guys, let's call it a day. You can get to work and practice these up, make sure it's super sharp, and I'll catch you in our next lesson. Way to go today.